Kia ora koutou, ko Douglas Walker, tōku ingoa. I'm here this afternoon with Sujata Rajagopal of Taita College. Sujata is the head of science out there, and we've just gone through structure and bonding, and we're now on to the organic compounds standard. So as ever, if you would like to ask any questions, pop them in the chat and we'll do our best to answer them. I might hold on to them, so don't be offended if I don't ask them straight away. I'll save them up and then maybe ask towards the end of the presentation when we've got a bit more time. It's great to have you with us, Sujata, and once again, thanks for all the work that you have put in, and thank you also to Study It, the MOE forums where you can go and ask questions of teachers regarding a whole load of your NCEA standards. All right, thanks, Sujata. Over to you.
Oh, hi, sir. Welcome to the Organic Chemistry. I'm Sujata Rajgopal, Head of Science, as Doug mentioned. What in this, as I mentioned in my previous webinar, this topic where we are talking about organic chemistry. Now, students, what I focused on this PowerPoint is more about your writing style. So I'm very sure that you have all studied, you know your contents, and what we lack here is when we look at it is your writing style. So when you wrote your derived grades exam, if you have gotten achieved, so it is very sure that you know your contents. Now what you have to focus is on your merit and excellence, and that is plainly your writing style. So if you have gotten achieved, you definitely know your content, and let us focus on your writing style. And I will show you some of the slides where I put what should be included in that, what should not be included, and what we are looking for is the key words. Now, only difference in compared to your organic and your other chemical reactivity topic is in organic chemistry. Remember, this is more about scientific processes, fair testing. So when you have questions on about how to identify, think of a situation when you are in a lab and what you would do first. So we are looking for the sentence, or first I would do this, this, this. Then I would do this, this, this. So there is a connectivity in your process, and how you're writing your method, your answers should reflect that. So I'll share the PowerPoint with you all, which I've prepared. So the external exam. Now, these are the questions, typical questions, which I've taken. What I've done is gone through the past few years of exams, and I've made a point of what are the ones which normally do not miss the exam papers. So we always have a question about the Cris and the trans isomers, and remembering it is a carbon-carbon double bond, the physical property questions. So what are the properties of an alkane or an alkene, and what when you talk about those things, and definitely the polymer questions, haloalkane, that is, a halogen is attached, then the alkane reaction. So those are the reactions when you're studying for your when you're finally revising. I would look at is take all your reactions, put it on an A3 chart, and look at which are ones which are similar, which are different, which are relating to each other. You will see that they are all relating to each other. There is a pattern, and that's a pattern and that makes it easier for you to answer this question. So, and when I talked about scientific fair testing, identifying the unknowns, which you also have done in your level 1 question, when they said, oh, there are 3 unlabeled bottles, they are all colorless, but we know this others, how would you identify? The same thing is there. Sometimes here they give you 5 different chemicals, and you have to say how you would distinguish between each one of them. So when you're writing for this, you have to be very careful. What we look for is, I will do this first, then this will be done, then this will be done, and go about. So a scientific fair testing process, a method has to be written in it. So your functional groups, you have the OH, the halogen, alkanes, alkenes, alkynes, haloalkanes, secondary and tertiary, the alcohols, amines, and carboxylic acids. So these are the ones which is there in you for your exams. You do not have esters and those things for you. That is at level 3. So your questions will be only based on this. So alkanes and alkenes, the main thing is to identify what is how many carbon bonds you have. So on that depends your naming. So if it is 4, you know it is methane. If it is 5, butane. 6, it is hexane. 7, it is heptane. So that's how you name it. And then what you have to do is when you are looking at when you're identifying the location. So whenever the branching you have to look at is where is the additional added, and from there you start naming them. So if it is on the first one, so you do not put 1, but if it is here, then where the additional branches, that particular carbon needs to have the lowest number. That's how you start naming it. And the prefix is ane when it is an alkane. And all alkanes are nonpolar. They are insoluble. They only dissolve in nonpolar solvents. And as the number of carbon chains increase, their boiling point and melting point increases. This is what we talk about the physical properties. Alkenes has one double bond. And you are looking at where the location of the carbon-carbon double bond is. Haloalkenes. Now see that I put sorry. The green color is where I put halogen. So it can be chlorine, it can be fluorine, it can be bromine, iodine, anyone. And what you do is that it is then you call it as a haloalkane. So the halogen, so chloromethane or fluoromethane, it depends on what is attached. And then in this one, what we have to look forward is the carbon being bonded to only one other carbon, or is it bonded to different ones? So if it is only bonded to one other carbon, then what you have is a primary haloalkane. If you have 2 carbons, so if this is your 1 carbon and there's another carbon to it bonded, and then you have on this side you have your halogen, then it is a secondary one. And if there are 3 bonded to it, then you have a tertiary haloalkane. And all haloalkanes are polar with only slight solubility in small. So if the number of carbons are less, it has a slight solubility. If it has more carbons attached, longer chains, its polarity increases. Alcohols. So again, alcohols, it is the location is the ending is OH, and you will call methanol, hexanol. So OL will be the end of it. So that again, the alcohols, you have the primary, secondary, and the tertiary. So if it is primary, how many? Only 1 carbon is attached to the other carbon. But if it is secondary, there are 2 carbons attached to the to one, or if it is 3 carbon attaching to the alcohol one. So that's what you're looking at. And also now, because this is a the alcohol is another functional group, where you have to look at is on the wherever it is attached, that particular carbon has to have the least number when you are numbering them. So that is that is very, very, very important, and we will go through those. And all alcohols are soluble in water because alcohols are polar molecules, and they have very high boiling point and melting point than the alkanes and the alkenes. Amines, that is it is ending in ane. So and that is what is attached to it is the amino group, which is NH2 group. So first at the end, so here there are 1, 2, 3, 4. So what you have to identify what is this chain, and here you see the amine is attached to this, and you have hydrogen here, and they are all weak bases turning red litmus blue. Carboxylic acid, the functional group is COOH and ending in anoic acid. So ethanoic acid, methanoic acid, or heptanoic acid. So that is because the ending has to change. The functional group num is COOH. Here, if you have only one carbon, it is methane, 2 ethane, 3 propane, butane, pentane. So we only normally go up till 8 octane. We do not go more than that. So when you are counting your numbers of your carbon, look at the long chain and then decide what that number will be. Okay? Yeah. So now if I look at this, 1, 2, 3, 4. If it is 4, what is the what would be the long chain? The long chain has how many? 1, 2, 3, and 4. So 4 means butane. So your ending has to be, the prefix has to be butane. But you see that on the second, so when I'm numbering the two, here luckily you have only totally 4. So either way it is there. So here it is, the first numbering will go from 1, 2. On the second one I have the chlorine. So it is a chlorobutane or 2-chlorobutane because it's attached on the second one. But here, see that in this one you have 3 and the chlorine is at the last one. So you don't need to say 1, but the 3. So what is your longest chain? 3 is propane. So, and chlorine is on the first one. So you don't need to say 1 or anything. So that's how you identify what it is. So the longest chain being identified. Now you know the NH2, it's an amine. Here it is a carboxylic acid, the group. So here this carbon will have the first number in this particular one, and this is the second. There's a methyl group attached to it. So the long chain is 1, 2, 3, 4, 5 pentane, and then you have the carboxylic acid here. So and you also have, so this carbon will be the first one, this will be the second one. So you have 2 methyl and whatever your 4 5 is there, and with your carboxylic acid group there. So that's how you are going to look at your naming ceremony. So sorry, naming in the nomenclature questions. Now, so this is again, this every time at what the students, what we have seen in our marking is every time students miss mentioning that the cis and the trans isomers can be formed only if there is one carbon-carbon double bond. And the functional group has to be attached on the carbon-carbon double bond. Otherwise, the cis or the trans cannot happen. And what the main requirement, see that link the presence of carbon double bond due to the lack. So now there the The functional group, two different groups have to be there, and they cannot move here and there just because of the presence of the carbon-carbon double bond. So what you have to insist on is a cis and the trans isomers can be formed only if a carbon-carbon double bond exists. Then there have to be two different groups have to be present on each of the carbon-carbon double bond, where those groups can change. So unless you say that, and unless you say that, you will lose your marks for writing this question. So this is one question which I've taken. The structure of three organic compounds are shown below. Explain why compound A can exist as a geometric, that is cis and trans isomers, but compound B and C cannot. So you can see that there's a carbon-carbon double bond here. This has one functional group here and the other can be attached to it. So two different functional groups there, and therefore it can happen. But here, there's a double bond here between carbon, but it does not have two different functional groups attached to the double bond carbons, and this definitely cannot because there is no carbon-carbon double bond. So what you have to talk about is using all your knowledge about that the cis and the trans isomer can only exist if there is a carbon-carbon. There are two main requirements. One is carbon-carbon double bond, and on that carbon-carbon double bond, two different functional groups have to be there. Otherwise, you cannot have, what you can have is, you cannot have a cis and trans isomers being formed. And students, this is at your level. This is an excellent question. So please follow that. Look at it. This is a clear example. Here is a carbon-carbon double bond. One side has CH, the other side has CH2. But here, carbon-carbon double bond, they have both CH2 on either of them. So it cannot be a cis or a trans one. And this has definitely no double-double bond, no carbon-carbon double bond. Therefore, you cannot have a cis or trans isomerism.
Got a few questions, Sujata. Would you like to answer those now, or should we hold them till the end?
No. They can ask me. Please ask me.
Okay. So there are quite a few. I might not ask all of them, but I'll get through as many as we can. There is a question about requesting clarification on which conditions require heat and which are aqueous.
Okay. When I come to that slide, can I answer that question, please?
Yeah. So if I think some of these questions might relate to things that you're going to talk about anyway, which is why I've been holding off.
Yeah.
Again, the students have been doing quite a good job of answering each other's questions in the meantime. So.
So here, when I'm looking at this particular one, they have the same functional group. So though there is a carbon-carbon double bond, it wouldn't do a cis or a trans. Now, why I put this is that when you go to no brain too small, there is a entire reaction summary is given where it talks about the addition and the addition reaction and elimination reaction. Now, what every time I remind my students is addition is the rich gets richer and the elimination is poor gets poorer. So what you see in an addition reaction is hydrogen gets added to the carbon. The highest will have the carbon which has the highest hydrogen will get more functional group attached to it. And in an elimination reaction is hydrogen gets removed from the carbon which has the least hydrogen. That is what you have to be very careful. And I have mentioned the addition and the the logo to remember is rich gets richer. And what is the key thing to remember is the carbon which has the highest hydrogen will get more functional group attached to it. And elimination reaction is the carbon with the least hydrogen will have that hydrogen taken away from it. Here it is, the addition and elimination and substitution reaction. So why I won't explain too much, because or you know your contents, but looking at this PowerPoint, you know what is happening. Where if to an alkene you are adding an hydrogen, it will become an haloalkene or an alcohol. But from them you are removing an hydrogen, it will become an alkene. Now, we're looking at with an substitution. So alcohol in presence of KOH aqueous, it will turn into haloalkene, or you can substitute with that haloalkene can be again substituted for a amine. Now here we are talking about the major and minor and haloalkene in presence of. Now remember, they are catalysts. They do not take part in the reaction. It is only the process that it can be substituted and made to elimination for the alcohol. So these are the why I'm not going into the major and minor products is because now is not the time to go into the topic teaching, but here I'm focusing only on how to answer these questions so that you are more well versed and getting through your answers to get your highest possible grades in your exam. I'll repeat again, students, you need to solve question papers, the past question papers, so to get a idea of, remember, NCEA is very systematic. It only there you can see a repetition in these questions. Why a repetition? Because the amount of reactions, the amount of questions we can ask is controlled by the curriculum. So the curriculum says is what all questions, what all reactions we can use, what are the where we have to restrict, what type of alcohol we have to restrict to, how many carbon chains can we restrict to. So that is what you have to. So you have to be very careful, and what you have to look at is the addition of the writing style. And this is the summary reaction which I've taken from the no brain too small and looking at what is major, what is minor, and answering. I'll give you a few minutes to look at it rather than I tell you, you might get confused. So look at it and see at this, and you can ask me a question if you want to. And if you all want it, I can share this PowerPoint with Mr. Doug Walker, and he can put it on the web for you all to see it again and go through it again. So when looking at the major and minor, major is where the carbon has more number of hydrogen atoms attached to it. Minor is where it has lost its hydrogen. The major and the minor being product being formed. So this is the chart where you look through the reactions, look at these are the similar ones which I've seen it repeatedly being asked. So we are limited by what we can ask. So you're lucky you don't have much to practice around, but practice is the key to your success. Now, this is what I'm looking at. Now, this is a question. So, okay, where you are identifying the reagent, the conditions, the type of reaction, the structural formula, rewrite the structural formula, and then say what is a major product there, what is a minor product. So if you go through with this once, and this is a style which you need to get your excellence in the answering the major and the minor products. Now, monomer and polymer. So, poly means the same one which is repeated. So, you're looking at which one is repeated, which monomer is repeated, and then on the basis of that, you start the naming. So, first thing is identify the monomer, then draw the so they will tell you it is if it is 5 times or whether it is 6 times, and you're drawing that with that monomer which is being repeated. Okay. Identify the carbon 1 and carbon 2 in the monomer side of the double bond, and then draw a chain with 4 repeating units or whatever it is. If they might ask you a 4 or 5, whatever repeating units, and add on groups of each one by and removing the double bond. So you are defining what is polymerization. You're describing the groups which is added to the end of the carbon bond. You're also describing what the structural formula, molecular formula is, and it's always an excellence question. So sometimes identifying the monomer itself is an achieved one, but explaining all these questions and making the unit, the repeated units, depending if they have asked you 4, please do not draw 5. Stick to the question and draw your polymer. Remember, when you're doing your repeated units, the double bond needs to be gone. So this is a slide which I've prepared. So what is a monomer? The monomer is the smallest repeating unit with a double bond. Polymers are long chains of monomers joined with single bonds. So when you're doing polymerization, the double bond is broken.
Got a good question that might be relevant just now, Sujata.
Yeah.
What if there was more than one double bond?
That then it doesn't happen in a polymer chain, because polymer chains can have only one double bond, and it wouldn't come up as so that, because whenever you are doing a polymerization, there can only be a single bond. There cannot be a double bond.
Lovely. Well answered. Thank you, Sujata.
No worries. So here the question. So this is one which I'm not sure which year it was asked. So you are identifying what is your monomer here, and you're going to go repeat it and remove this double bond. See how I've written? I've written with a pen. I'm not sure whether so this double bond has gone, and then I repeat it, the Cl, Cl, Ch, then again Cl. So this is how you add the repeating units. So the repeating units is one full session. So then you keep on adding to the polymer. And there is no double bond. So when you are repeating it, the entire thing has to be repeated. So this consists of, when you are adding that, this part consists of one monomer. So you are attaching the whole thing. So together of that to make 4 units, 5 units. This is every time we have seen it, this type of questions have never missed the organic question paper, is of identifying organic liquids. Now, while identifying the organic liquids, what you have to learn is you have to write it, as I said previously mentioned. This is a particular question where we are looking for a scientific fair testing method being written as. So first you will do this, second you will do this, and talk about what are the reagents you're going to use to test them. So you have to know your reactions for each one of them. So now the reagents are given to you. So, and they tell you what you have is ethanol, ethanoic acid, hextuene, and 1-aminohexene. And what are the reagents given to you to identify? They are acidified dichromate solution, bromine water, sodium carbonate solution. So you have to identify, okay, first what am I going to do? I'll put so and so in this one, and this will react with this will, so I know this is this. So further, I will do the testing. Now remember, when you're doing your scientific testing, when you do your experiments, once you have got the answer, you do not stop it there. You trial it again to find out whether that is correct or wrong. So is there another test you can do on the same to verify this is that same solution? And that's how you write about. This is the only question in organic chemistry where we are very particular about, has the student written first they will do this, then they will do this, and is there a link to show that you are going to do it in a scientific fair testing method. If that is not there, then your chances of getting an excellence on this question is negligible. You at the most, if you have identified, you might get an achieved, but because you have not written the scientific fair testing process, you will not get an excellence. And for this particular question, we are very, very particular about. That's the end of the. Yeah.
Sorry, Sujata, just on that one, with the fair testing procedure, do you need to specify exact volumes, like, X number of milliliters of one and X number of milliliters of another?
No.
Thank you.
No. It is only telling them first you would do this one, okay, and then I will do this. So you're showing a systematic order because you're not testing, we are not doing a scientific experiment as such where the volume, everything has to be the same. But what we are looking is, do you know the procedure, how to eliminate one by one, and how will you do a repeated test to ensure you have identified the solution? This paper is very, very short paper, but why I would say take long time to answer it, so that you are very careful about your nomenclature, you're very careful about your cis and trans, because they are the ones which will give you your excellences. And they are not hard, but are you look through it, because sometimes your reactions in your hurry, in your panic mode, you might tend to forget. So be calm. And what I would, which I mentioned earlier too for this topic, again, any exams, please take a highlighter with you. But when you're taking a highlighter, remember it should not be excess bleeding of the ink, so that when you turn the page, you cannot read the other questions. So a light, and do not underline the entire question. Look at the keywords. What do they want you to? Now, when I'm looking at this question, write excellence answers to identify. So what I would look is identifying unknowns. They are the two things. I will not identify the whole thing. Now, in this question, the four separate colorless organic liquids. So I'll say colorless, ethanol, ethanoic acid, hextuene, and one amino hexane. These are the words I will underline or highlight. Reagents I will highlight, and acidified Cr2. If I want the words, I will, or I will just identify the symbol, bromine water, sodium carbonate. So I know these are the keywords I have to use, and I will do that by writing first I will do this, second I will do this. So that is a procedure to go through, and they are very, very particular at level 2 to look at this one.
Sujata, are you going to give us a step-by-step breakdown of this one in terms of the answer?
You want an answer for this one? Okay. Yeah, I've written an answer and kept, and I will show you how to do it. Just let me stop sharing this, and I will get to you. Give me a second. Here's a 2013 question. 5 separate colorless organic liquids: penta-1-nol, ethanol, pent-1-ene, pentane. Write a valid method to show how each of these liquids can be identified using only water, litmus paper, and bromine water. So when you read this question itself, you know that it's a method they're asking you, a scientific fair testing. So now, though I've written here as water, I would say first I would add water to all the 5 liquids in the test tube two of them will dissolve in water, and that is ethanol and which is the other one? I'm sorry, I can't. Yeah, ethanol and ethamine will dissolve in water. Pentavanol, pentavanene, and pentane will not. Then what you have to distinguish is, then since you have got two of them, you take that. Since two of them are dissolved in water, now I would add litmus paper. Secondly, I would add litmus paper to the test tubes in which water has dissolved, and red litmus paper to both the solutions. One will not change the color of the litmus paper. This is ethanol. And the one that will turn red litmus into blue is ethamine. So here they have only mentioned red litmus paper. You will also say, to doubly confirm that this is ethamine, I will take a blue litmus paper and put a blue litmus paper in ethamine to see if it is changing color. If it remains blue, then that particular solution, that test tube is ethamine, and the in one which the litmus paper did not change color was ethanol. Am I making sense of how to write the answer?
I think so.
Yeah. So this is because this question asks you, it clearly says that if somebody follows the method you have written, then they should be able to do it. That's what we have been telling you right when you started doing experiments, that your method should be such that if somebody tests it, they should get a similar answer, result. Any other questions?
Oh, lots, yes. Could we go over any carboxylic acid reactions?
Okay, give me a second. Let me take the reactions. Just give me. Okay. Yeah, this is an acid-base reaction in carboxylic acids. So, carboxylic acid-base reaction in presence of amine. What are you getting? Carboxylate ion. Any carbonate. It is typically an acid-base reaction because carboxylic acid, it's an acid. So, and then you have any carbonates, obviously you will get a carboxylate salt, depending on what type it is there, what is the type of the carbonate, and the water, and definitely carbon dioxide. This is one. Any other reactions you would like to see?
Yep, we've got a request. Could we please go through the special conditions? Could we please go over all the special conditions, which reactions require heat?
Okay, which reactions require heat? Okay, not a problem. Mhm. Show the slide that is much more easier when they look at it. So yeah, just a minute. Before I for one thing which I wanted to show the students was I'll just share the screen before I go back to students. This one of the things which you need to know is that while sometimes you are given an alkane and an alkene, so this whether you have to distinguish between in that identifying of solutions where the most of the alkanes and alkenes are colorless, so you have to know that whether what would be the reactions with bromine water. Normally bromine water is given. So with alkenes, it will immediately change color, whereas the alkene takes time. So that's how you identify between uh, alkane and an alkene. So let's say a pentane and pentene. So pentane with the bromine water, it will take time, and you keep it in sunlight. So you have to say that you and you take if you're taking bromine water, so I will put bromine water in both the test tubes and keep them in sunlight, and if the color fades, if the orange color fades slowly, then it is a pentane, and if it immediately changes color in presence of sunlight or other UV light, it is a pentene. So these are some things you have to, and when then you double check. Now remember I told you whenever you have identified a solution, you have to give a second proof of that whether it is the correct one or not, and that is here potassium permanganate. When added to an alkene, it will not change any color. It will show the potassium permanganate is purple in color. It will remain, but in an alkene, it will change to a colorless solution immediately because an oxidation reaction is happening. And I'll come to the ones, just give me a second, where you have heat. Okay. Okay. What happened? Give me a second, Pip. Sorry, students. Sorry. Yeah. Okay. Yeah. So can you see that? Normally it is the addition reactions which require heat, where you see that alkene, when in presence of hydrogen and platinum and heat is supplied, it changes into an alkene. Alkene, when you put in presence of hydrogen gas and platinum and heat is supplied, changes to an alkane. And here, whether an alkene with presence of water and heat changes into an alcohol. These are mainly it is to do with an alkane, alkene, and alkyne reactions where you need a heat. Others, if you are just doing a substitution reaction, the bromine or chlorine, it is changes to a haloalkene, and there you have in presence of either HCl or HBr, an alkene changes to an haloalkene or an and you have minor and major products. So most of the addition reaction of alkenes come with hydrogen and presence of platinum for the and heat has to be supplied. Any other questions?
Yeah. Ramiro's asked, do we need to know the other names for types of reactions such as hydration or dehydration other than substitution and addition?
Either one is fine. If you want to know it, if you can say it, that's fine. Because when you are saying it is a addition, you are saying rich gets where additional hydrogen is added to the carbon, which has the more number of carbon atoms, more number of hydrogen atoms attached to the carbon, and elimination is where the hydrogen is removed from the carbon, which has the least hydrogen. So it is understood. So you don't need to mention hydration or dehydration, nothing of that sort. No marks are not deducted. As long as you tell what is a addition reaction or what is a elimination reaction.
What reagents are used to change alkene to alcohol? I think this may have been on one of the earlier slides, but
yeah, it's there in the slides. Yeah. So to change it into alcohol, you can have either alkene. Normally you need water. In presence of water and heat, it will change into an alcohol. That's mainly for an alkene changing into an alcohol.
Stacey's asked if you could please clarify which functional groups get number preferences, or is it methyl groups?
No, number preferences is when to the carbon you are first doing is identifying a long chain of carbon, and the when you're numbering it, you have to number it with whichever way you number it, the functional group where to which the carbon is attached should have the lowest number. And when you're writing, it is in alphabetical order. So ethyl will come first, though ethyl is on the second or the third and the methyl is on the first carbon one, let's say, then but while writing, it has to follow the alphabetical order. Let's say the methyl group is attached on the second carbon atom and the ethyl is attached to the third carbon atom. It will be 3 ethyl, 2 methyl, whatever your prefix, the number of chain of it is.
Brianna's asked, before you said 1-aminohexane, can you also name it hexane 1-amine?
Yes, you can.
Thank you. I've put the link to the website with the resources you were using, Sujata.
Yeah.
But if you could remember to share your presentations with me,
yeah, definitely.
I will put them in the description.
Yeah. No Brains Too Small and also GZ science resource. They are good ones which also tell you if you look at it, but it is only giving you a synopsis of how to write the answer. but you have to follow the link properly.
And a follow-up question to the one a moment ago. So does the methyl get number preference or bromine?
It depends on which is coming first. So if bromine is attached to the carbon atom, when you're numbering it, it is going to get the least number, then the bromine gets preference. But while writing, so if let's say your methyl group is attached to the second carbon and bromine is attached to the third carbon, so you will write 3 bromine, 2 methyl, whatever your long chain is. Have I answered it?
I hope so. I'll give the students a moment in case they're not sure and want to ask for any clarification.
Yeah.
Olivia's asked, do you have to warm acidified permanganate / dichromate for oxidation?
Yes, slightly warm.
How important would it be to state that in the exam?
No, we are not, because they're not telling you whether you are going to heat it or not, but they are only asking for a method, and that method has to be very clear.
Right.
The more confusing is especially when you have been given, you have to be very careful, because they will give you an alkene and an alkane together. So are you reading remember NCEA also tests how well you're reading and collecting the information. So are you distinguishing between pentane and pentene? Both looks familiar, but one is an ene, one is an ane.
I think this should be a nice, easy one. You've covered it before, but it might be worth stating again. How do you know which carbon is carbon 1 for counting?
Okay, carbon 1 for counting. So you have to look where your functional group, look at your long chain first, then look for all the functional groups. So in one of the functional group, when you're numbering it, it should be such the functional group to which the carbon is attached has to have the lowest number.
And I'll just pop in this question in chat. I think it's just looking for clarification on the naming.
Mm-hmm.
So if there are 4 carbons, bromine's attached to carbon 1 and methyl group is attached to carbon 4, would you number the carbons starting from the methyl group or bromine?
From bromine.
And there's some discussion over when a hydrocarbon becomes less insoluble, after how many carbons?
It doesn't, but most firmly it is more after 4 carbons. It becomes, as the chain increases, it becomes less soluble.
And there has been a bit of discussion around the use of water. I think that was turning the alkene into alcohol. And question, just could you clarify whether it is water or dilute acid?
It's water. Alkene to alcohol is water in presence of heat.
Water in presence of heat. Okay. Yeah. And when do we use the cracking observation?
What's it? Sorry, I didn't get it.
I think it's relating to cracking.
Oh, okay.
And the question is, when do we use the cracking observation?
Okay.
Could you clarify that one for me?
Yeah, I
will. The student who's asked that, and then I'll ask it of Sujata again.
Yeah. Just give me a second. It's better to show them the slide for it, because Let me share. Okay. Yeah. So what you need is, you need, now cracking only happens with alkanes, and what happens is the larger the chain, they want to break it into shorter ones. So you have to have high temperature and pressure, and in presence of a catalyst, that's when it is only happens with alkanes when with the chains are very, very long. Any other question?
I've just popped a link in. There's still a little bit of discussion around whether it's a dilute acid or water for the alkene to alcohol.
Okay.
So I've just popped a wee link in there that will hopefully be useful to people.
I would suggest they could go to No Brain Too Small, and the entire reaction summary chart is given so that they can look at it.
Yep, and I've popped that one in chat as well. I'll put that in the video description as well once I've got those presentations from you, Sujata.
Yeah.
We might finish off with this one. Will cracking come in the exam? I thought it was more around level 1, but Sujata's got more recent knowledge of level 2 than I have.
Yeah. So no, cracking do not come in because it's just a statement. They are not. It is not looking at any reactions for y'all. So it is. I've not yet seen that question ever come in level 2, and I've even in when I've been marking, I've not seen it come there. So I've had to see it. It is just a statement, a physical property given to you as an information, remembering that alkanes are more petroleum products, and you need to make it shorter to get it into the different usable states. So that's it.
Lovely. Well, thank you very much, Sujata. We're slightly over time there, and we'll wrap up. If you've got, I mean, there was a huge number of really good questions in there that we maybe didn't get around to answering all of them. And so, if there's things that you're still not sure of, if you pop your question in the Study It forums, we'll get those answered for you. Thank you so much, Sujata. Really appreciate your time, especially the weekend. And we'll look forward to catching up with you for the third standard in level 2 chemistry.
Thank you, Doug, and thank you, students, for joining in. I know it is an important time of the year for you all. Hopefully, I've answered your questions, and all the best. You can do well.
Hakite.
Takite.